The following Zoom session is being recorded and will appear later today on my YouTube channel, Math with Mayo. There are two different classes that may be observing this session. Therefore, when you participate in the Zoom meeting, if you do not wish for your picture or your name to be made public, please leave the video off and use an alias name. If you have questions during the meeting but do not wish to speak, email me at bmayo@ybcc.edu and I'll respond as soon as I can. Okay, so I had a couple of requests yesterday through email. So this is from section 6.4, number 18. It says factor. If the expression is not factorable using integers, enter the word prime. Now, the student, what they did was correct. They just didn't finish, and I will explain. So here was the original problem. 2p to the fourth minus 32q to the fourth. Taking out the greatest common factor, we get 2 times p to the fourth minus 16q to the fourth. But p to the fourth minus 16 to the fourth, minus 16q to the fourth, excuse me, is the difference of two squares. You could have p squared squared minus 4q squared squared. So then you'd get 2 times p squared plus 4q squared times p squared minus 4q squared. And this is what the student had. They were in a slightly different order, but they had this. But this isn't finished yet because this is also the difference of two squares. It can be factored further. You would have p squared minus 2q squared. Let's see, so you would get 2 times the quantity p squared plus 4q squared times p plus 2q times p minus 2q. So this factors further into that. And that's the final answer. Any questions on that one before we go on? Okay. Next up, we have problem number 26, also from 6.4. And it says, choose the correct method to factor the following completely. 50 in s squared minus 100 in u plus 150 in. Okay. Wow. Well, the greatest common factor is 50 in. So we take out 50 in and we have s squared minus 2u plus 3. Now, we can't factor s squared minus 2u plus 3 any further. This is the final answer. What the student who asked about it did, they wrote prime. True, this can't factor any further, but if it was prime, we wouldn't have been able to do anything, and we were able to take out a greatest common factor. So the answer should be this. All righty. Well, that's all the questions I got requests for. Do any of you have questions before I go on? Anybody? Anything? Okay. So section 6.6, which we're going to look at today, doesn't have anything new. It just kind of throws all the different factoring methods together into one section. And so what I want to do is kind of lay out a checklist of things to do to factor. First of all, I want to point out that the author has, or authors have their own checklist on page 477. So if you don't like mine, you can refer to theirs. Okay, my checklist looks like this. Step 0.5, yes, 0.5, I'll explain that later, is standard form. Okay, step one for day-to-day is take out the greatest common factor. Step 2 is binomials. Look for the difference of two squares. Step 3, trinomials. We're going to have a Roman numeral 1, 2, and 3. And 1 is to look for, we'll say look for perfect square trinomials. So that would be in the form of x plus a or something like that squared. 2 is the form x squared plus bx plus c, where the leading coefficient is a 1. And so you factor it, pulling apart that first term, and then you look for the product and the sum. And 3, ax squared plus bx plus c, and you're going to use grouping or trial and check. Step 4 is factor by grouping. Step 5 is, are you through? And step 6 is check your work. Okay, so if we have a polynomial, the first thing we want to do is put it in standard form. Then we want to take out any greatest common factor. Then looking at what's left, we look to see if there's the difference of two squares. If so, we factor that. If it's a trinomial, first we see if it's a perfect square, then if it has a leading coefficient of a 1, and then if it's neither of those, we use grouping or trial and check. If there's 4 terms, we use factor by grouping. Are you through? For instance, the problem I just did earlier with this one, where the student stopped there, they weren't really through, they could have kept going. And finally, check your work. All right, now, why do I start this thing on 0.5? Because then it works out nicely. The number 1 is take out the greatest common factor. You're taking out one thing. Step 2 is binomials. Step 3 is trinomials. Step 4 is factor by grouping, which typically has 4 terms. So that's why I did it that way. Also, standard, I didn't spell that correctly. Standard form applies to trinomials or larger. If you have a binomial, it's more important that it's written as a difference, if possible, than if it's in standard form. And we looked at that earlier. Okay. So I'm going to be referring back to this list. If you need me to go back to it during the problem, say so. Otherwise, you'll have it on the video later as well. But here we go. So let's start with, how about this one? 2b squared plus 8b minus 24. Is it in standard form? Yes, it is. It has b squared followed by b followed by no b at all. So it's a trinomial in standard form. Is there a greatest common factor? Yes, a 2. So we'll take out the 2. The trinomial that's left over, is it a perfect square? No, it's not, because we've got minus 12 at the end. But it does have a leading coefficient of a 1. So we would split it apart, b and b, and then we'd look for a product that's negative 12 and a sum that's 4. How about 6 and negative 2? Since it had a leading coefficient of a 1, we put those numbers right in there, and we're through with that. Can I factor either of those further? Well, b minus 2, that's a binomial with a subtraction sign, but it's not the difference of 2 squares. So we're through, other than to check our work. Now, to check my work, I can multiply it back together the same order I took it apart, or I could do it a different way. I'm going to go ahead and do it a different way. So I'm going to start by distributing 2b plus 12, and then that times b minus 2 2b squared minus 4b plus 12b minus 24, 2b squared plus 8b minus 24, and it checks. So this is the final answer. Any questions about that particular problem? All right, we'll continue. 32 minus 2 t to the fourth power. This is a binomial. It's not in standard form, but it's written as a subtraction problem, which is what we'd want if it was the difference of two squares. So rather than turn it around and factor out a negative and all that, I'm going to just leave it. But the greatest common factor is a 2. So I get 16 minus t to the fourth power left over. Well, 16 is 4 squared. T to the fourth is t squared squared. So I've got 2 times 4 plus t squared, 4 minus t squared. Am I through? No, because even though I can't factor that further, I can factor that further, the difference of 2 squares. So that's 2 squared minus t squared. So I get 2 times 4 plus t squared, 2 plus t, 2 minus t. And there's the final answer. Any questions on that? All right, let's take a look at, let's see, this one. 6r squared plus 3rs minus 18s squared. Well, this is a trinomial. It has 2 variables, but it is in standard form in terms of r squared, r, no r at all. It has a greatest common factor, which is a 3. So we'll factor out the 3, 2r squared plus rs minus 6s squared. Okay. Now, that trinomial, it's not a perfect square. It doesn't have a leading coefficient of a 1. So I'm going to use grouping or trial and check. I prefer grouping. When I'm done, if anybody wants me to go back and use the trial and check, let me know, and I'll be happy to do it that way. So A is 2, B is 1, C is -6, the product is -12, the sum is 1, the numbers are 4 and -3. So this becomes 3 times 2r squared plus 4rs minus 3rs minus 6s squared. Splitting the middle term into 2 terms, whose coefficients are these 2 numbers. Coming back and using grouping, we have 3 times, let's see, the greatest common factor of the first 2 terms inside is 2r. So then r plus 2s. So r plus 2s minus 3s, which gives me minus 3rs minus 6s squared. So I've got 3 times r plus 2s times 2r minus 3s. Now, this is the difference. It's a binomial, but it's not the difference of 2 squares. So that's as far as I can go with it. Okay, any questions there? All righty, let's see here. T minus 90 plus t squared. Well, this is a trinomial, so standard form is important. It's not in standard form, so I'll rewrite it in standard form. Okay. There is no greatest common factor other than a 1. It is a trinomial. It's not a perfect square. It does have a leading coefficient of a 1. So I can do this. The product is -90. The sum is 1. So the numbers are 10 and -9, plus 10 minus 9. Now, t minus 9, that's a difference. And 9 is a square, but t isn't a square. So I can't factor that any further. Any questions there? All righty. How about this one? AB squared minus 4a plus 3b squared minus 12. Well, this has 4 terms. 4, I gotta get my hand up there so you can see 4 fingers. Standard form. Well, standard form is a little bit tricky there because we only have a and we have b squared, but let's see what to do. We're gonna try and group it. Let's see if we can group it just like it is. There's no greatest common factor other than a 1. So if I group it just like it is, the greatest common factor of the first 2 terms would be a, and it'd have a b squared minus 4 left over. Can I pull out a b squared minus 4 for the leftovers for the second part? Plus 3? Yeah, I can. So now I've got b squared minus 4 times a plus 3. Be careful, we aren't through yet because this is also the difference of 2 squares. That is b squared minus 2 squared. So I've got b plus 2 times b minus 2 times a plus 3. Something like this often gets overlooked on a test where people do something and they're all excited. Oh, I factored it, but they're not done yet. So be careful with that. Let's see here. We have 6t to the 4th plus 14t cubed minus 40t squared. This is a trinomial. It's in standard form in terms of t. There is a greatest common factor, 2t squared. So I have left behind 3t squared plus 7t minus 20. The trinomial inside the parentheses is not a perfect square. It doesn't have a leading coefficient of a 1. So I'm going to use grouping. Again, if anybody wants me to go back and use the trial and check method when I'm done, let me know. Otherwise, I'll continue. A is 3, B is 7, C is negative 20. The product is negative 60. The sum is 7. Well, that one looks a little bit tricky. Let's see. Oh, how about 12 and negative 5? Does anybody want me to spend any more time how I found those numbers? Okay, well then I'll continue. 2t squared, 3t squared plus 12t minus 5t minus 20. Oops, wanted that in red. Doesn't really matter. Factoring by grouping. Now I get the red when I didn't want it. Okay, let's see if I can get my colors together here. 2t squared. The greatest common factor here would be 3t, t plus 4, t plus 4, and a minus 5. 2t squared, t plus 4, 3t minus 5. It's really important that you master factoring because we'll be using it in the rest of this chapter. We'll also be using it in chapter 7. So it's going to be around quite a while. Okay. Let's see here. How about this one? Negative 9x squared plus 6x minus 1. This is a trinomial. It's in standard form. Its leading coefficient is negative, so I'm going to factor out a negative 1. Okay. Now, what's left inside looks like it could be a perfect square. That's a perfect square, that's a perfect square, and there's a plus sign there. So let's see if it is. I don't need this 1 out in front. I can just put a negative. So let's see if I can take this. 9x squared would be a 3x and a 3x. Plus 1 would be a 1 and a 1, but it would have to be minus in the middle. Does that give us minus 6x? It does. So I could write the answer like this or like that. And again, I don't know if WebAssign would mark it wrong if you put a 1 there or there. Haven't investigated it. Does anybody check that out?
Yeah, I think it works both ways.
Okay, all right. But I would definitely make sure before the test, because but again, if that was something where if it was marked wrong because you had a 1 out there, I would catch it and I would give you credit for it. Okay. Let's see here. How about let's see this one. A squared plus 8a plus 3. So here's a trinomial. It's in standard form. There's no greatest common factor other than a 1. It's not a perfect square. A squared is a perfect square, but 3 isn't, at least not using integers. But it has a leading coefficient of a 1. So it's going to be a, and the product is 3 and the sum is 8. Well, the product's positive and the sum is positive, so both numbers have to be positive. So the only possibilities are 3 and 1, and that doesn't add up to 8. So this is prime. And again, it says to write, when in WebAssign, it'll say to put it in capital letters. Be careful, because if you write it in lowercase letters, I don't know if it would count it correct or not. Certainly not if it was as sloppy as I wrote it. Yeah, so follow the directions. Okay. How about this one? U squared minus 18u plus 81. That's a trinomial. It's in standard form. There's no greatest common factor. Oh, it has a square up front plus a square at the rear. So let's see if this is a perfect square. You'd have to have a minus. That would give you minus 18u in the middle. So that or that, either of those would be the correct answer. Okay, how about this one? X cubed minus 25. Well, this is a binomial. It's in standard form. There's no greatest common factor. It's not the difference of 2 squares. So it's prime. How about this one? X to the 6th minus 4x cubed minus 12. Well, this is a trinomial. It's in standard form. There's no greatest common factor other than a 1. The leading term, x to the 6th, that is a perfect square. It'd be x cubed, the quantity squared, but 12 and a minus sign at the end, it's not a perfect square. But it does have a leading coefficient of a 1. But instead of breaking apart x squared, I'm breaking apart x to the 6th. So I get x cubed and x cubed. Okay. So I'm looking for a product that's negative 12 and a sum that's negative 4. How about negative 6 and 2? So then we get that situation. Okay. And neither of those are the difference of 2 squares, so they don't factor any further. About this one, x times x minus y times x minus y. Well, the greatest common factor here is x minus y, and we take that out of both of those, we'd have x minus y from there left over. So we've got x minus y, the quantity squared. So either of those could be written as the correct answer. Let's see here. How about this one? 24 minus x cubed plus 8x squared minus 3x. Well, the first thing I'm going to do here is put this in standard form. Negative x cubed plus 8x squared minus 3x plus 24. Oops, I didn't need that parentheses there. But my leading coefficient is negative, so I'm going to factor out a negative. Which will give me that. Now I'm going to use grouping inside. So I've got this, which is going to be, let's see, the greatest common factor of the first two terms is x squared, and I've got an x minus 8 there, an x minus 8 there, and a plus 3. So negative the quantity x minus 8 times x squared plus 3. Okay. Any questions there? All right. 25b squared plus 14b plus 49 over 25. Oh, the directions said factor using rational numbers. So they no longer need to be integers, they could be fractions. Sorry, I didn't mention that, but that's going to pertain to this problem. So this is a trinomial in standard form with no greatest common factor, but it could be a perfect square trinomial because 25b squared is 5b, the quantity squared, and 49 over 25 is 7/5 squared. That wouldn't be a plus, but just my point is it starts with a square and ends with plus a square. So what's that going to look like? 5b, 7/5, 7/5. My middle term is positive, so that would have to be plus. Well, that gives me 25b squared and 49 25ths at the end. Does it give me 14b in the middle? Let's find out. Let's see. 7/5 times 5b is 7b, and 5b times 7/5 is 7b, and 7b plus 7b is 14b. So yes, it is a perfect square trinomial. So you could write it that way, or you could write it that way. Okay. How about this one? X to the 4th minus 13x squared plus 36. Well, this is a trinomial. It's in standard form. There's no greatest common factor. It starts with a square and ends with plus a square. So let's see if we can do this with it. It would have to be negative in the middle to get minus 13x squared, but this gives us minus 12x squared. So it's not a perfect square trinomial. However, it does have a leading coefficient of a 1. So we could look for a product of 36 and a sum of negative 13. How about minus 9 minus 4? But x squared minus 9 is the difference of two squares, and x squared minus 4 is also the difference of two squares. This is one of those questions that's like a math teacher's dream because it has you factoring a trinomial, looking to see if it's a perfect square, and then factoring the difference of two squares. It's got just about a little bit of everything. Okay. Well, that's about it for today. I think I've given you enough factoring to do. So tonight, section 6.6. Again, I will be back this afternoon at 1:15. If you should have any questions then, I'll stop the